This video is going to be about the important algebraic technique called completing the square. An important skill while you're trying to complete the square is to recognize perfect square trinomials. A perfect square trinomial is a trinomial that could be factored into a binomial squared. Let's look at an example. First, we have x squared plus 8x plus 16. If I was going to factor this, I'm going to notice that my leading coefficient's a 1, so I can probably factor it without going through the grouping process. So I need to think of two numbers that multiply to 16 but add to 8. Those numbers are going to be 4 and 4. So I would have x plus 4 times x plus 4. And I can actually, since I have the same term twice, I can rewrite this as x plus 4 squared. So that's what I mean by a binomial squared. So a second example is x squared minus 10x plus 25. Well, two numbers that multiply to 25 and add to negative 10 are negative 5 and negative 5. So I'd have x minus 5 times x minus 5. Again, I have the same binomial twice, so that's really just x minus 5 squared. You may be observing a pattern here. The important thing is that a perfect square trinomial has an x squared in the beginning, and then a number squared at the end, a perfect square, and then that middle term is 2 times the square root of the last number. So to be more concrete, let's look at the second example. I have 25. The square root of that is 5. Notice that shows up here in my binomial squared. Well, 2 times 5 is negative 10. Looking at the first example, I have 16, which is 4 squared, and 2 times 4 is 8. And my answer has x plus 4. So that 4 is really the key number. So in a general equation, when my binomial squared is x plus b, my perfect square trinomial would be x squared plus 2b plus b squared. Now let's look at a few examples of finding what's missing to make a perfect square trinomial. The general process I want to go through is taking my coefficient on my x, dividing it by 2, and then squaring it. So this would be 8 squared. So I would do plus 64 here. In the second example, I'm going to take my negative 20, divide that by 2, square it, so that I have negative 10 squared, so I'm going to add 100. Now the third example is a little tricky because 5 over 2 doesn't come out to an even or a whole number. It's a fraction. So I'm actually just going to leave it as 25 over 4, where 25 is 5 squared and 4 is 2 squared. So I can just write it as 25 over 4. Now, in general, what you're going to do is take the coefficient on the x term, so in my last example, a g, divide it by 2 and square it. So the general formula looks like g over 2 all squared. Making a perfect square trinomial is easy enough, but we want to use it to turn one side of an equation into a binomial squared and then put everything else on the other side. And this is a little bit harder. So let's look at this example. When I try to do this, the first thing I'm going to do is get rid of my c term, or my last number that doesn't have an x. And I'll get rid of it by subtracting it from both sides. So I'll subtract 45 from both sides. Now I'm left with x squared plus 6x equals negative 45. Now notice I left a blank. This blank is exactly like the blank in the previous few examples. We need to figure out what to put there so that this whole left side is a perfect square trinomial. So I'll use my trick of taking the 6, dividing it by 2, and squaring it. So that's going to be 3 squared, or 9. So I need to add 9 here to make the left a perfect square trinomial. But if I add 9 to one side, I have to be careful to add 9 to the other side as well. So in the end, we're just going to jump down here, I'll have x squared plus 6x plus 9, which is a perfect square trinomial, equal negative 36. And then I'll rewrite it in the end as x plus 3 squared equals negative 36. Now at the moment you may not see why this is useful, but it's a really important skill that we will need in class while studying conics. I'm going to do another example now, and I'm also going to list out the steps so you have something to reference. So remember, the first thing to do is to move that constant, meaning it doesn't have an x, to the other side. So now that it's subtracted, this time I'm going to add it to both sides. So now I have x squared minus 12x, and I'll leave my blank, equals 7. Now my second step is to look at the middle term and take the coefficient, divide it by 2, and square it. So now I have negative 6 squared, so that's going to be 36. So I'll add 36 to both sides. Make sure you do it to both sides. The last thing to do is just simplify everything. So on the left, I know I have x minus 6 squared. And remember that 6 can be found here as the number I originally squared to find that 36. It's really just b over 2. And then that equals 7 plus 36, so 43. And I'm done. Here's a more complicated example. I'm still going to start the same way by subtracting my constant from both sides. So now I have 2x squared minus 28x equals negative 25. But before I go dividing b by 2, I need to realize that I have this 2 out in front, and that's going to mess everything up. So the first thing I need to do before I do anything else is factor that 2 out. Take out the GCF. So it's going to be x squared minus 14x blank equals negative 25. And it's actually this x squared minus 14x that we're going to turn into the perfect square trinomial. But we have to be really careful about this too. So that's really going to complicate things. But let's go about our business taking my negative 14, dividing it by 2, and squaring it. So that's negative 7 all squared. So that means I'm going to be adding a 49 in here. Now this is where it gets a little bit harder. So I'm adding a 49 inside the parentheses. This 2, though, is outside the parentheses. So what I'm actually adding to the left side of my scale, or my equation, is 2 times 49. So I've really added, in a way, a 98. So I have to make sure when I actually add to the other side, I add 98. So this 2 times the 49, 98, so add that to the other side. So I now have 2 x squared minus 14x plus 49, which I know is my perfect square. Have that equal 37. And now I would write it as 2x minus 7 squared equals 37. And depending on what we're using it for, we may be dividing by the 2 out here, but for now we'll just leave it like that. Okay, I'm going to do one last example of this slightly trickier type, and I'm going to put up the steps as well so that you have something to reference. So I still start by adding the constant to both sides. That's what you're always going to start by doing. So now I have 3x squared plus 9x equals 2. Now this is where we need to add that extra step and factor out a 3 from the left. So I'll do 3x squared plus 3x plus blank equals 2. Now a good question to wonder here is, well, what if 3 didn't go nicely into 9? And you won't see that too often, but you would still want to factor out that 3. So we'll look at examples of that in class, but for now it should work out. Okay, so now I'm left looking at this part, x squared plus 3x, and wanting to complete the square. And now I'm also left with that kind of messy situation where 3 over 2 is not a whole number, but I can still square it. So that's going to be 9 over 4. So I'm going to add 9/4, oh no, inside my parentheses. Now remember though, that means I'm actually adding 3 times 9/4 to the left side. So it was really 3 times 9 over 4. That's 27/4. That's a whole lot more fourths than just the 9/4. So on my right side, I know this is a little messy, but I'm going to add 27 over 4 to keep it balanced. I hope my description of step 3 over here makes sense. I'm just saying b over 2 being this coefficient, this 3, divide by 2, then square that whole thing. And then we multiplied it by 3 before we added it to the right. All right, now let's clean this up. I'm going to write this as 3 and then x plus 3 over 2 all squared. So that's my left side of the equation over here. If you remember, this part of the binomial squared is always just this number, this 3 over 2. So whatever we had before, we went through this squaring part. So I have that, and then on the right, I unfortunately have a fraction addition. I have 2 plus 27 over 4, and just for fun, I'll make a common denominator, so that would mean the 2 needs to go multiplied by 4 over 4, which is just 8/4. So I would add 8 and 27, and I would get 35/4. So my total final answer is 3x plus 3/2 squared equals 35/4. And that was a particularly nasty one. Hopefully you don't see many like that. All right, so to finish off your homework, if you could do these 4 problems, in the first group, you're just finishing the square trinomial. So pick the number that will make each a perfect square. And then in the second group, you're going to do the balancing the equation, where you want the square binomial on the left and then a number on the right. And these are not as nasty as that last one I just did. Good luck.